So first seeing here about the iterables. What are iterables? Why we need to work on them? I already told that iterables means objects that support looping on them. Means objects that support iterating. Iterating means looping. So based upon that, objects can be classified as two parts. One is like a non-iterable objects on which we cannot loop, when iterable objects on which we can loop. So these are two types of data types. So as we know, if I apply say for loop on an integer for each digit in 1, 2, 3, 4, if I ask to print the digit, so will it print? No. Whereas if the same thing was placed as a string, because string is a iterable object, so we can get each digit at a time. Assume that the same thing was placed in a quotes, means or like in braces, then it works. If the same number is there, like this also, means only iterables we can work. In the same lines, if you work with the strings also, strings are also iterable. String doesn't mean number as a string. We can have string in different ways. We can get each character at a time. So like that. And similarly, if you have a collections means I can go for a list, tuple, set, and dictionary. So one thing we can understand is that in collections, whenever you're iterating, so in a list, when you iterate, you get each value at a time. Tuple also each value at a time. But in set, we can't be sure about the order in which the things are coming. That's the only difference. But things were fine. If I say Uday, Prakash, someone, I got in the same order for list. So tuple also in the same order. But in the set, we cannot expect the order to be same. It may or may not be same. So sometimes it's gonna be. And also when iterating, so one more thing what you need to remember is when iterating on a dictionaries, by default when you iterate on a dictionary, you will get only the keys. So that's also I told. If you explicitly ask dot keys and iterate, you get keys. If you explicitly ask dot values, you get values. But if you ask dot items, you get like both key and a value. So like that. What do you think? That is okay. I need to define a type. Yeah, sorry. First, I need to define the dictionary. Yeah. So what I'm doing? Yeah. First, I'm defining a dictionary. Names equal to first so and so, second so and so, third so and so. By default, if you iterate, you will get only the keys. So, but like as you know, if you want both keys and the values, you are supposed to give them. If you give directly, so this is what happens. So this is what we already learned. Just I'm giving a gist. So, and if you want both keys and the values, you go like this. When you're getting two values, you can assign to two variables. That is also we have seen. At the same time, and so you already know that whenever you have an iterable, we can do a for loop and we can get the loop index. Means when you have like a for character in a Python, so what you do, you ask for character, you get it. But in the process, if you want to get the loop index, so I already told that loop index comma character in enumerate of the same Python string if I give, so I can print both loop index and a character, right? This is for ordinary characters. But can we do the same thing even for this dictionaries also? So dictionaries, if let's say assume there are two elements are coming. So, but if you are doing like a index also, if you want, then what you can do? I can say like a loop index or like index, whichever I want. And this end result I can pass to the, so enumerate. If I pass to the enumerate the keys, when you are iterating on a dictionary keys and values, you get keys and values. Apart from that, you get this also. So, but this is one thing that everyone as a beginner will face an issue. So what is the problem is that at one shot at a time, it will give one value and two values together. Means, so you need to do a slight difference. Here, I need to place a brace. Observe very carefully. When you enumerate, you get a loop index and the value, right? The loop index is loop index. Apart from that, you get a tuple of 2 values. Because the entirely it is giving one separate value, one tuple. That's the reason if you assign like this, then it will work. Hope you understood what I'm trying to say. So when you want to assign to multiple things, you should be sure about that. If you do directly, it's gonna not work, but in the other way, it will work. So this is most important point. You need to be aware. Next, one more thing is that whenever you have a tuple, this concept of unpacking, whenever you're doing, so looping with unpacking concept. So that's what you're seeing for quite some time. Looping with unpacking. In this looping with unpacking concept, if I say I have a list which is having each one a tuple containing 4 elements. One at a time I can get, such that each tuple will have the entire tuple value. Or like as I'm getting 4 values, I can assign to 4. Or if I'm getting, so I can assign like this also, right? Instead of 4, I'm assigning to only 3. But did you see that I placed a star? So the moment I placed a star, what will happen? So to make the things to understand in one at a time, so if I assign all to one thing, that is how it works. But as I know that I'm getting 4 values, I can assign to 4 values and I can get it. So individually all values. But what if, though I'm getting like 4 values at a time in each loop, I'm assigning to only 3. So that's the reason the concept of asymmetric unpacking. The star in within that makes a lot of difference. So when I do, so the first 2 values were given to it. The third value means remaining got to the remaining. This is the concept of unpacking. And also I told the concept of converting anything to a list tuple set. If you have a Python program like a string, I can convert that to all these things. But if I try doing with a dictionary, will it work? The same Python program, if I ask, it's gonna throw in error. Because dictionary for creation, it needs a pair of values, like a list of tuples or list of pairs, list of lists or like tuple of lists, whatsoever. So how do you create that? We create using zip. And zip expects 2 things, the same Python program. And apart from that, you give some numbers, say range of 9. Then range zip will create some values. So by default, you cannot see them. You convert to the list so that we can see the results. And based upon this zip result, we can get the dictionary. So this is what our learning. If I do, you got it now. This is how you do it for dictionaries. Next, the enumerations, which I told earlier. So enumerations and other things, which we already discussed about the enumerations, but just to give a list, enumeration.ipyn. Okay. So as we discussed just now about the enumerate, how we are working on different things. If I create an environment, enumerate means to get the loop index. That's what we have seen. So traditionally, if you want to get the loop index, say I have defined a string and I want to get the loop index. Say like I defined one string called as my string equal to program. Now, if I want to get the loop or the values, so generally I do what? I loop over the values and I can get like each character. But during the process, if you want to get the character and the count, loop count, then you create a variable called as counter equal to 0. And every time you do a counter plus equal to 1. And such that you can ask, hey, what is the value of counter and this one? If I do now, I get the value and the counter together. If you don't want to do like that, explicitly if you want, you can do what? You can use a enumerate function. But enumerate function, will it do on its own if I directly execute? No. If I convert to a list or a tuple, so then you will see. So for that only, I told that when you loop, you can better understand. So enumerate if you apply every time. So how many values are there? it will give the loop index. So whenever you're getting a pair of values, you can assign to two variables such that you can do whatever the statement you want. And similarly, when you're doing this enumerate, we can also give the start. Loop doesn't mean every time it should start with 0. We should give the second value called a start. If you don't give, by default it is a 0 start. But if you give some value, it will take that. And similarly, if I take one more thing, if I take start equal to 4, then what happened? So the loop index starts from 4 when you're looping. So when it started from 0, it has gone till 6. But when you started with 4, it has gone like that. Similarly, I can give like a -3. So when I give -3, you can see that it is going from -3 till +3. So whereas you need to understand that whether you go for a range or even here also, you should not give a floating point value step. Means index every time will start with integers only. So that's why we should not give a floating point values. So this is what also we understood about iterables. So next good thing about iterables is all, any. All and any, these are two built-in functions. I think like these were the only functions which I didn't tell till now. So apart from that, a couple others. What are these all and any? So how they can help? So first to understand, till now we have worked on functions. To understand this, hope you remember we already worked on something called as a bull function till now. Bull function means I told this is a function which we don't use on a daily basis, but in the backend the same logic will execute. So for us to be aware of how things are working in the backend, it is one kind of way to help. So whenever you give any integer, we know that, like say if I give boolean of 0 or like 1, I get like, okay, I need to convert back to markdown to Python script. Okay, see now what happened? It is saying boolean of 1 is equal to true. In the same fashion, if I say boolean of 0, that will be false. So that's what I saw now, right? And boolean of strings. So if I have a string of some values, I get the value, I get as true. And if I give like a boolean of even a white space, that is a true. And if I give like a boolean of empty string, then it will be false. So it's in the same fashion for true, false, all these things I told. So based upon these things, if you want to apply for a given list of values, say I was given a list of values, and for this entire list of values, I want to know whether each of them are like boolean true or not. Then what is the process to do it? So first is like you loop over each of the values. For number in, so my list, you loop over each of the values and you print number comma boolean of number. You see now what happened? The list of numbers, you are getting whether true or false, any of them. Now this all or any, how they work, I will tell you. So all means what? All will be true if boolean of each of the element is true. Here everything is true or not? No, one of them is false, right? So now how the logic we need to write is, so when everything is true or not, we will do. So how I will do? I will check every time what is the boolean. So sometimes it will be true, sometimes it will be false, right? All will be true only if every time boolean is true. Means whenever it is boolean equal to false, means is false, in that case you want to do something else. So that's it, right? So whenever it is so and so, it is not true, maybe like in that case I want to print why something is not correct, and I want to maintain something like a I can break the code. I can break the code. So, and for a for loop, typically we can have an else condition also. In else condition, when else condition will execute? When all the loops were executed, the else condition will execute for a for loop. Hope you remember. In other cases, it will be so fine. So then what I will do, as we are still not into the functions concept, I will create a flag. So like a flag equal to true here, result. So whenever something is wrong, I say result equal to false. Now after your work, you need to write, hey, I want to print so my list and the result. So this all, if you want to check, you need to write this much logic. Instead of you writing this much logic, in Sharply we can do with one single function called as all. You need not do a for loop, you need not check all the things, you need not write like this logic. Just you do all. If everything is true, boolean true, then you get the result. If you see the all, as here everything is not true, it will be a false because one of them is 0. But for the same all, if I give one of them which is 0, I change it to like a non-zero. See, as everything is boolean true, the result is true. In the same fashion, if you want to implement any also same logic, means like here what happens, if at least one of them is true, the result is true. Then like what I need to check? I need to check for boolean trueness. If something is true, I can break there and stop. If nothing is true, then I can make it false. Instead of I doing that much logic, I can use a simple any function. So that's what the conclusion to tell you is that this all and any work on any data type, mainly iterables. They work on iterables only. So you can take like a say list. See, in this first case, all were true, right? Boolean true. So that's why both any also will be true, all also will be true. All means what? Everything should be true. Any means at least one of them is true. Whereas in the second case, see here, all of them are true except one in the first case. But even one of them is false, entire result is false, right? In the any, everything is false, but one is true. If at least one of them is true, entire result is true, right? And in the same fashion, if I go like this, in this case, what is that? I told boolean of none is false. So as one of them is false, so it works like that. So not only this, you can apply not only on a strings, also we can apply for strings also. If you see what happens, in the first case, I have a word Python, entirely everything is true. But in the second case, I have a white space. Even white space is also true if you can observe carefully. So white space is also a valid thing, right? So I have white space. This is one of the interview questions which was asked. So Python was given. Even this after t, the empty string is also boolean true. That's the reason. So the reason why I'm telling is simple. When you apply boolean for the empty string, it will be false, but at least white space, it will be true. So this is what we have seen. And in the same fashion, we have seen about the different case of working, like sorting and others also. I think I need not tell much. So then going further, we have iterators. Same like iterables, there is one more concept called as iterators. It may be confusing, but don't worry. The name is only same, but slightly. So you'll once you start understanding, it's easy task. So first, to understand what is an iterator, let's understand the existing object which we learned till now, which is the range object. Range. So what is this range object? In Python 2, if you see everywhere, you will see that the range is one of the function. It will not create any data type. In Python 2, it is just creating like a list only, the list of values. Whereas in Python 3, there is a separate type called as a range. Means generally for values generation, we have this thing. But this whenever you create, it will not give you anything because it is an optimized object or a lazy loading object. What do you mean by this, sir? Means they are designed to be optimized. Means why they have designed like that. Earlier in Python 2, the application used to be crashing very frequently. So Python is the most unreliable thing. So the reason because whenever you create a range of say 10, 0 to 9 values used to create and store. Where it will store in the heap memory only. So someone has created 1,000, someone created 10,000. All the values will store here only. Then your program will become more bulky. Say the private heap is not sufficient for anyone. Then what happens? Your code won't work. So your application will crash if you don't have enough memory. To avoid that, they made this kind of optimized object. Optimized object means if you ask the values, it will say, hey, I need to give a state. Means they will store the state that, yes, I need to give the values from 0 to 9 with a step of 1. That's it. So whenever you ask, they will give value. Means they storing a state will not take much memory, right? Storing the entire values will take memory. So that's what happens. And this is for if you want to get the values, what is the solution? I told when from range, if you want to get the values, either you for loop on it so that you get all the values, or secondly, we can convert to other data types. Other data types like list, tuple, set, and dictionary. Of course, dictionary we cannot convert, but we can convert to other data types. I created to convert to list, tuple, set, and a string also. If you are converting to list, tuple, or set, it is like an iteration. Whereas if you are converting anything to a string, it's not iteration. Just modification. That's it. I would say. That's the reason when I converting to string, it is not giving values. Fine. And similarly, if you want to convert to string, this is not the correct way. So if you want to really convert to strings, first we need to iterate and convert, right? So like that we need to apply like a delimbed dot join and we need to do. But that's okay. You understood that range is an optimized object. But did you observe that you can apply for loop or you can apply any of the loops any number of times you get to it. So it is not a pure iterator. If someone says range is a iterator, no. Why you are not calling it as an iterator? To understand that, let's take the examples that we know till now that we have seen. So for the optimized object, the next important things is about zip, map, and filter. Zip, map, filter, which we have already seen. If I can focus on it, if I have like two iterables. So basically, this zip, map, iterator, these are like iterators. How they can help is that they are optimized objects for sure. So they are lazy loading. So lazy loading, even range is also lazy loading and on-demand computation. And the most important points, iterators are disposable objects. Means once you get, you cannot reuse again. So for the range, once you create, how many times you are reusing? Whereas you cannot use those many times here. Means how, sir? Let's see. Let me take two iterables. First, I'm taking one string, so one set and one tuple. I told that this zip, map, filter we can apply on any iterables. But when you apply on sets, you can't be sure about the order. That's the one thing that we know. And if you want to create the pairs, this is how we create the pairs, right? You do a zip of it. Generally, zip will create an optimized object. It will not give the values. If you print also, you can see the same. It is of type zip and it's a zip object. And if you want to get the values from a zip, what is the solution? Either we need to do a for loop. If I do a for loop, I get the values. Or second, I need to go for converting to other data types. So let me try converting to other data types, how we have seen in the earlier case. If I go again, so same like in a range, I'm doing here also. But did you see, when I for looped on it, I got the values. But when I'm converting to other data types, I'm not getting. Does it mean that when you convert to other data types, it will not work? It's not like that. So the main problem is, so iterators are disposable objects. You can get a value only once. Once it gives the values, you cannot get it again. If you really want to get it again, so we need to first reassign and get it. Means if you want to reassign, say like I again create the pair. So pairs is equal to zip of alpha and numbers. Then from that I convert to a list and ask the values. So this pair I converted to list and I'm asking the values. Now I get the results. And again if I want, again I need to reassign and ask. Means once you get the values, you cannot ask get again. So it's like a disposable object. So means again I cannot and convert to a set and you get the values. Or like again I take and convert to a string and get the values. String will not convert, but fine. But as it's a zip, means it gives a pace. We can even convert to a dictionary also. Yeah, that is also possible. But one thing you notice the difference between a zip and map is this one. So what it extra does compared to an ordinary range is, if you in an ordinary range you define once, but you can ask any number of times. But only when you're asking only it will give one value at a time, like a on-demand computation. Whereas in a zip and a map or a filter, what it actually does extra, so it is like a disposable. Means once it gives a value, we cannot expect it again back. That's what one thing happens. I did with a zip. You can try with the remaining map and filter, as we already see. The same thing. With these things, I want to work on user-defined iterators. What do you mean by user-defined iterators? Means we can also create our own iterators. So how do you create? So if you want to create an iterator, iterators means primarily you need to understand like this. For any iterator, if you want to create, we need to use something called as iter protocol. There is something called as iter protocol. Till now, for every function, we call it as a some function like range functions or any other function you call. But this is one function, we call it as a protocol. Means there were some set of rules in the backend. That's the reason we call it as a protocol. So means iterators is an immutable, disposable, and lazy object. So observe everything. It is a immutable object, I'm saying. Means once you define an iterator, we cannot change the things. And we can get values only at a time. How do you create that? They don't come from the sky. So we create based upon our iterables only. So first, let's say I have a list. It's a list of some values. If I ask, hey, what is the type? It says it's of type list and you get the values. And if you ask what's the length, it gives the length also. And as it is a ordinary list, I can ask even indexing, slicing, all the basic things I can do. Or I can do list operations, whatever it is supporting. Everything is fine. Whereas if you want to create a iterator, I need to use the iter function. I have alpha is a list. That alpha I need to pass to iter function. The moment I pass to iter function, it becomes an iterator. And it is called as a list iterator because it's created from a list. Or even if I can assign to a variable and then ask the same thing. So as this iterator is created from a list, it is called as a list iterator. So from this iterator, once you created, so I can just display, that's it. Did I get the values? Nothing. And if I ask, hey, what is the length? It throws an error. Means we cannot get the length, nor we cannot get the, okay, leave it. So can I get the index at least? No, we cannot get the index also. So as we cannot get the index and all these operations. So this is all we understood. We can't do. So, but fine. Sir, can I do the list operations? Because alpha is a list. So same like alpha IT is also a list, right? Should be. Because it's created. But we cannot do. Means though it is created from a list, we cannot do list operations. Means iterator means only designed to get values. That's it. So then in which case, sir, we need to use? Whenever you have a very large data you are storing, for better management, we use a iterator. Then what is the solution? Once created, only retrieval. Retrieval means you can loop on it, get the values one at a time. Or else I told that we can convert to other data types to get the values. But so you know, right? If you convert to other data type like a list, you get nothing. So the reason is simple. So means what? Whenever you want to get the values again we need to create and we can use it. Means once it is created, we can use only once. So now we see here, again I can create it, I can use it. So if I want to convert and use it, you see from a list, I created a list iterator. From that, if I want to convert, I convert it to a list. Similarly, I can convert to a tuple. So original values are list, I convert to a list iterator. Then finally, I'm changing those values and getting values like this. And if I want to convert to like a set or a string also, I can do. So this is what you understood. On the existing list, you did it. Now, let's take the example again. So this, you understood briefly what is an iterator. This iter protocol, nothing we do, just pass to the function, that's it. To conclude the different types of iterators, if you can focus there. So first we can see, I created a list. This is a list, right? I took a list. From that list, if I create a iterator, so I pass that list to an iterator, then it is called as what? List iterator. Similarly, if I take a tuple and convert that to a iterator, that is called as a tuple iterator. I created a tuple and I'm asking the type, it will say tuple and the values, and then passed that tuple to a iterator. Now you see it is called as tuple iterator. I'm not joking, it's clearly like that. And if you pass a set, it is called as a set iterator. So I passed a set, so it is converting to an iterator. And in the process, we have like different things. So means when you go for a dictionary, it is very interesting. So when you pass a list iterator, tuple iterator, set iterator, whereas for dictionary, there is very different. By default, you pass a iterator. It is called as a dict key iterator because when you loop or a dictionary, by default, it gives only keys, right? So that's the reason when you pass to iterator, it will take only the keys. And its case a dict key iterator. But if you explicitly pass dot keys also, it is called as dict key iterator. If you pass values, it's called as dict value iterator. And if you pass items, it is called as dict items iterators. It's a very interesting point, right? And the last part of it is that even if you pass a string is also an iterator. Sir, in which case we use string iterator? Assume that we have a large text and that we want to process. When you are working, you want to handle large data of a string. Then you create an iterator. So iterator means like it will make the data to be optimized in such a way that it will not load too much. It will get only when needed. So next you will see when you are working with large data sets, you will use these concepts. But fine, why I'm going for all these concepts? Means so simple. First of all, if I go a bit of explanation, till now we know that the objects are of two types. One is non-iterable objects and other one is iterable objects. Ultimately, we want to handle large data and Python application should not crash. So what they decided is like these basic data types like int, float, none, so and so, they will not make any change. They were but the same. It makes no difference because they are already optimized. Whereas these iterable objects, a string can have how many characters? There is no limit, right? So a list can have how many values? No limit. Means these all have practically no limits in Python. Means we can accommodate a very large data. Then how to optimize it? For that, for range, they created this range object. So they created a range type in Python 3. So for handling large data. In the same fashion, for iterables, whatever we have, if you want to optimize, we can use the iter built-in function or iter protocol, whatever you call, and we can create. As I told just now, for strings it is called as string iterator, list it is called as list iterator, tuple iterator, set iterator. For dictionaries, three types of iterators. So this is what I told. Next, not only this, we will further work on next on something called as user defined functions. User defined functions also have a large computation. If you want to optimize that, there is something called as generators. So we need to use generators for that concept. So before going to there, the last two concepts I will tell you. So user defined iterators, till now you understood how to use it, right? Let me tell you a couple of things. So iterator usage dot ipynb. So we created an iterator. This iterator, how to use this? Usage. Okay. Iterator means, so there are two ways I told. Whenever you have an iterators, in terms of usage, I told that, hey, either we can apply for loop or like, so you can iterate or that using a for loop or convert to things. So these are the two things we have seen. Now I will tell you a new function called as a next. This is another built-in function called as a next. What it does, I will tell you. Let's say I have a list. So assume that, I have coins like, maybe like I have a paisa. So, so 1 rupee, 100 rupees, 1,000 rupees. Assume I have some coins. These coins I want to work and I want to iterate. I created some coins. Now I create an iterator. Coins iter. So maybe like symbolically for us to better understand, I use it. I passed an iterator and I'm asking dot coins. Now it creates an iterator. And if I ask, hey, what is this coins iterator? It says it's a list iterator because we created from a list. If you want to get the values, till now what we know, we can apply for loop on it. So for each coin in so and so coin iterator, we can print. So each coin is equal to something you wrote. So this is how you got the values. But after that, if you ask again, it will not give. So that's what we know. So it is a disposable object. Once it gets, it will not give again. But like, if you are converting to another data type. But the problem is that what? Till now what we have seen? Again you do, but convert to other data type. Means like if I do a list of coins iterator, means every time either you do like a for loop, you get all values, or you convert to a list or a tuple or a set, you get all values. But I am not interested like that. I am interested one value at a time. So if one value is needed, so if one value is needed, so in that case, again you construct the constructor. So coins iterator is equal to iter of this coins. I create it. Now after creating it, I will ask, hey, so what is this coins iterator? It says it's a iterator. Fine. Now there are two ways in which you can get the values. I can use coins iter. If I go for the DAR of it, DAR will give the list of attributes, right? Even if I ignore the things which have underscores on either side, do I have any other choice? No, I have the same thing. But within the hood, there is something that I want to tell you. There is something called as underscore underscore next. For the first time you're seeing. Means this coins dot underscore underscore next. If I give, I get the first value. If I use the same thing, coins dot underscore underscore next. Coins iter dot underscore underscore next. So like that, you get one value. So either you can use this attribute or there is a built-in function called as a next. If I use that also, I get it. Okay, initially how many you define? So 4 coins till 10,000, right? So 1,000 you define. You already got like, so paise, so 3 values. And if I go for the next one, coins iter, I got the 4th value also. Means either if you go for this or this, you get one value at a time. But here there is one problem with this mechanism. So how many values it have, it will give. But beyond it has capacity, if you ask. Means we have given only 4 values initially. If I ask after 4 values, it will give this exception called stop iteration. So that's the reason whenever you have this kind of scenario, we need to handle with a try exceptions. So how we do is like a try. So means whenever in the last case, whenever you have a doubt, we can say a stop iteration exception. So as ex. So we can print. Generally, in the stop iteration exception, you don't get the value. It will be an empty mostly. If you see, it's a stop iteration exception. So generally means if you want to get all the values in this scenario, so what I can do is that I can say again coins iter is equal to, so iter of coins I do, and I do in a while loop. So in a while loop, if you want to get the values, how to get the values? The for loop means it's easy. Then how to get the things in a while loop? This is how. Say while true, you can do. So like every time if you ask next of this coins, you get one value at a time, right? That you are sure. But some point it will throw in error. That also you are sure. So you do a try. So whenever you get the values, say print. So coin, whichever the coin you got, you display it. And except stop iteration exception. Generally, stop iteration exception will not give anything. So you are done. You don't want to do anything. Maybe like you don't want to do anything. Once everything is done, you just want to skip, or else so you want to break the loop, because else you, where you will break, you want to break the while loop. You want to get all the values. Did you see using while loop also I got all the values? So this is how we need to work. And similarly, next we have something called as generators. What is this concept of generators? How they can be helpful means, whenever I told you, so when you want to get an optimized objects for a non-iterables, there is nothing needed. For iterables all, so I told we use iterable function. But for user defined functions, if you want to make them optimized, we have generators. So how to use these generators? So before one more point I want to bring to your notice is, see, there is based upon these iterators, there is something called as Iteratools. Means when you have an ordinary list, so we can do add to a list, we can add two tuples, we can add to, so some different tuple, we can do operations. But once you get an iterator, what else we can do? Just getting values, is that the only motive? No, we need to do some operations also. So on these optimized objects, if you want to perform some operations, we need to go for a tool called as Iteratools. This is in fact a module. And generally in a Jupyter notebook, it's a best practice that all module imports we need to write in the first line, so that anyone who is coming to the project can understand. So we are using ordinary string, random, and operator modules, which I will tell. So here, any module if you are learning, first we need to use __ doc. It will give the entire documentation. So like basically what all things it is doing. So initially about the infinite iterators, it is giving operations for infinite iterators we can create. Means infinitely we can create values out of it. So similarly, we can also create some kind of different things, and like a combinatoric generators. So all of them we will see shortly. And if you go for help, there is a slight difference. Help has a one predefined structure in which everything will come. So that's the difference between ordinary underscore docs and help. And apart from that, if you go for dir, it will give the list of attributes. If you see the list of attributes, it has a long list of attributes which are supported. The first and foremost is accumulate. Hope you remember, earlier I told, when you have a range of values, if you ask a range of 10, so range will create 10 values, means 0 through 9, means it will go till the last value but doesn't include. Whereas if you go for accumulate, itertools.accumulate, so what it does is that, so from on any iterable, if you are looping, you take anything. So when it is giving the value, till there, whatever the value is, it will give that. Means initially the value is 0, right? And 0 plus 1 is 1. Next 0 plus 1 plus 2 is what? 3. So that's why you got 3. Next 0 plus 1 plus 3 is 6. You got it. Means till that position, what is that sum? So that cumulative sum, whenever you want, you can go for this. So not only this, if you pass like operator.add, means by default cumulate will do a cumulative addition. What if you want cumulative multiplication or something else? Then you can give. If you don't give also, by default it will give cumulative addition only. Or explicitly you can give operator.add. So it will do the cumulative addition. You see, it will repeat the same thing. But if you want like cumulative multiplication, you can do operator.mul. So you get all zeros because the first value is 0. Range will create a values from 0 through 9. So that's the reason when you multiply with 0, everything is 0. But if I make one of them as 1, so means if I start from 1, then you will see the difference. So this is cumulative multiplication. So, and similarly, hope you remember about the permutations and combinations. So if you give A, how many permutations we can have? Only one element. So one thing. But if you have two elements, so there are two possibilities. Means like A, B and B and A. So two possibilities are. Whereas if you have a 3, so means like A, B, B, like that. So there will be 6, right? 1, 2, 3, 4, 5, 6. 6 combinations. So similarly, if I want to have recursively, so we can also give return x successive n length permutations. If I say r equal to 1, means permutation should be only 1. Like that, how many are there? Permutation should be 1 only. Means in each one, there should be only 1. So earlier you didn't give that r equal to 1. That's why you got like 2 combinations. So whereas if I give r equal to 1, in each one, there should be only 1. Similarly, if I go for the next one, see here, r equal to 2, means each one there should be 2. Or if I don't give r equal to none also, it will give how much max it can do, that much it will do. So if there are 3 characters, max it can do 3, right? So that's why it will do. So or if I give explicitly 3 also, that much. So means each one in that how much it can do. If I give like r equal to 2 now, so though it can accommodate 3 combinations, I'm asking only 2. So similarly, combinations means like if an item in a sequence is sorted, then combinations will be sorted as well. That's the reason it's better to sort them as possible before doing. If I do a combination, in combinations means 2 combinations you are asking, but there is only one element. So if I ask like A and B, the combinations, that's the reason permutations they call as selections and this is combinations like that. So in combination, see, if I say B, C, 2 at a time I need to have. Each one there will not be repetitions, right? The same thing will not come again. Of course, there is again duplications also, which I will tell afterwards. If I say I want 3 pairs, 3 combinations, pairs combinations, or if I say 2 pair combinations, so if there is a duplicates within your thing, there will be duplicates. If you don't want duplicates, ensure that you are passing unique values. But at the same time, for these combinations, we can also pass like with replacement. With replacement means you are telling that, hey, for these combinations, if I do without combinations, just A and 2, as A is like only one element, you don't get anything. But if I do with replacement, you get twice. But if I give like AB, so in ordinary way, you get only one combination. But if I do with replacement, reverse also will come. So means AA, AB, VB. Means duplicates were not there earlier. Now we can see within the same pair, duplicates will come. Though there were no duplicates here. That's a difference. So like a combination, different kinds of combinations you can see. So like that with replacement, etc. Next one is about compression. Compression is very interesting thing. So to understand compression, so how we need to understand is, you need to take one list or a tuple or any iterable, and the second one should be like a Boolean values. In the second list, so in that position, if the value is Boolean true, you get that first value. Observe carefully. As for A, there is a true. For false position, B. So for false is for like C. That's why again true is for like B. So that's why you got only that characters. So to whichever characters you have the position like that, you get only them. Hope you can relate now. So true means A you got. So D you got. E you got. A, D, E you got. Similarly in the same fashion here also. So means you may ask me, sometimes there can be asymmetry also, sir. Means for this how much it is needed, it will check that much. If the values are less than this, it will ignore them, remaining values. So the corresponding, if it has a 2 billion truths values, it will give it. And see, this is a very easy expression to understand. Apple is there, you have only 2. That 2 also falses. Now see, you got it what? First 2 positions, you got zeros. So exclusively first 2 positions. So AP. So even 0 is also a string, right? Means how it actually works is, when you give like this, in the back end, what it happen? It will convert to a list of strings. When converted to a list of strings, the first one will be a 0 as a string. The second one will also be a 0 as a string. 0 as a string, Boolean true or false? Boolean true, because it's a string, it's not a number. So that's why the 0th value and first value you will get. In the same fashion, if you pass exclusively like this, 0, 0, then nothing will come. Hope you understood the difference. And similarly, if you have, you can do with the group by. Group by means, I will tell you one interesting point. Next, you learn about the random function, where random.choice means among these values, one value will be picked. I took something like that, and I'm saying k equal to 20 means from these randomly some 20 characters will be picked. And if you want to sort them, so generally we use sorted function to sort it. Every time understand this one point. Anytime when you are going for group by, in Iteratools or in pandas also, it's better to go with the sorting first. Because if you are sorted only, the results will be correct. In a database, things are different. But here, there is some problem. So that's the reason we expect it to be sorted first. Iteratools. For Iteratools to work, first the value should be sorted. That's the reason I'm sorting. If I don't do sorting, I will get like different groups. That is a problem inherently here. So once I sorted, and if I'm doing group by, did you understand? So for each character, it will make like a group. So in the F group, did you see the F was repeated these many times? So H was repeated these many times. Like that, for every character, it will create like a separate groups. So that is the concept of group by. So similarly, if I have some values, you see some numbers are there, and I have A, B, C, C, E, D, something is there. Now, if I want to group by, I think if I group by these numbers, you cannot understand much. But if I give by these alphabets, I think you can understand. ABC, you can relate. ABC is coming twice. So CED is coming twice. BCD is coming twice. Like that it is coming. And if you want to group by, I can pass the data. Key is equal to lambda x stated x of 0. Means each time if you are given one tuple, in that go for the 0th value or first value. I am asking first value. If I pass like that, it will group now. Now we see how many values are there uniquely. Those many groups will happen. So ABCD, in the ABC only one is there. BCD is coming twice. That's why you're seeing that. But did you see that ABC is coming twice, but did you see things are different? So that's the reason I told we need to have sorting the groups. As the ABC is not sorted, it is literally creating two groups for ABC. Though ABC is coming only, so like that. But if I sort them and if I ask further the data, did you see this time the groups are like this for ABC2, CED2, like that. So that's the reason we need to sort them. So, and next thing, the group by, when you're grouping, we can also give some kind of custom grouping. If you see here, I am checking whether something is even or not, and I am sorting based upon that. Means first evens, next odds, like that. If you want to sort and you do, like that I can do, and I can get it. You see now what will happen. So I created a function, and I'm creating some random values. So random.sample means it gets random values, and I want to group them based upon this. Now we see within this, what are the even values group, odd values group. I created like that to you. So like this, I can give some custom functions. Means grouping by whether a custom functions also I can do. This is very much interested and it's needed in the real time. And next, if you want to count something, these are kind of like infinite, so generate iterators, as the name says. Iteratools.count of 10. By default, you got nothing. And if you ask the type, every time it works with iterators only. Even if you ask type also, it says iterators only. And for this x, which are the x you created, you want to loop, you are looping like from 0 to 30, you are looping. 30 times you are looping. So you gave the count of 10. Means from 10 onwards, how many times you loop, you get every consecutive value. You are every time asking next of x. Means from iterator, if you want one value, you need to use next. But did you see what happened? It's like a infinite sequence. What are the value give, it will take that as the first value. From that value, it will create any number of values. If I say iterator.count of 3, from 3 onwards it will generate. If you loop for 30 times, from 3 onwards, in plus 1 plus 1 like that till 30. So that's why you got values. Similarly, if I say, so initial value and a step, till now you want like every next value. Initial value, if I say 3 and the step is 2. So every time the value will be 3, 3 plus 2, 5, plus 2, plus 2, plus 2, plus 2, like that you get. Similarly, if I give initial value is 3 and a step is like 5, you got. And similarly, if I give initial value is 3 and step is -1, you got it. So like that you can create infinite series. In the same lines, if you want to do an islice, same like how we do a slice. In fact, there is a built-in function called a slice in Python, which we seldom use. So we directly use indexing, right? Slicing. So like that we can do. Means from this islice, it will create a values of 0 to 9. From that, if you want to get the 5 values, so you didn't give anything. Means from 0 onwards till 5 you want. Till 5th value got. Or like if you give a counter of 10 minus 1, means from 10 with a step of -1, you want to generate values. And from that you want to get 15 values. So you see here, it's kind of like from 10 onwards, 10 -1 -1 -1 till 5, 15 values you got. Similarly, so means islice is for like getting a chunk of it. How many values you want, you can specify. If you just give only one value, you are telling how many values you want. But if you give two values, so you can say like, after generating the values, what is the 5th value? From that 5th value till the 10th value you want. Or like from that 5th value till the 10th value with a step of 2. With a step of 2 in the generated result. So the values will be like every time -1 only. in the generated result. In the same fashion, so dot cycle. Cycle means like counter means what? You give a initial value. From that value, every time it will generate the values, right? Next plus value or minus value, like that. But cycle means you give one list or a tuple or anything. The same values it will repeat. Every time you loop over it, the same values it will repeat. Those many number of times. Did you see head tail, head tail, head tail, head tail? So if you give like head tail, you loop for n number of times. It's up to you. Did you see that I am breaking? If I don't break it, it will loop any number of times. So means it can generate infinite amount of values. So cycle is for giving the same list values, again repeating again and again. Counter is for giving the numbers based upon what you give. Whereas repeat is one thing. So this repeat also does the similar thing like cycle. But what it does is that the same values, all values it will give. So in a cycle, cycle, within the given list, you get one value at a time, each time. Whereas repeat, whatever the values you give, every time it will give all the values. So that's the difference. But if for the repeat, it is not like an infinity. It is a finite thing also. Means if you pass like 4 times only it will give that. If I pass like 3, it will give 3 times only. So like that. So the repeat is not an infinite. And similarly, if you want to join multiple iterators, say I created iterator from a list, from a tuple, from a set, so from a dictionary, items like that I created. I have like these many iterators. If I want to combine them, so we can add two lists. Means list concatenation is possible, but we cannot add two list iterators. Though they are like iterators, we cannot add them. So then, like if you have the same, so did you see both are list iterators only, but still you couldn't add. So if you want to join, we need to use iterators dot chain. I'm using list every time because for us to better analyze. So if you pass like 2 or 3 any iterators, it will join the values of all of them. And if I have 2 iterators and if I join them, I get a list of iterators directly. It is not like joining the values. But if I have like this combination, I can pass this combination. If I pass that combination directly, it makes no sense. But if I do a star, then it will give all the values outside. Means like unpacking, then you can join it. Means if you have, you can create your own tuple and place all the values, or like this. Or else if you have 2 iterators and you create an list from it and you pass like a from iterable. For from iterable, you need not give the star. Means unpacking is not needed. It will do unpacking on its own. And one more thing is in the zip function. Hope you remember when you work with the zip function, when you have 2 iterables, it will zip both the things. But what I told is that if the number of values are not equal, so if you have any values which are exceeding, if you see in this case, only 3 are like pairs. The remaining values don't have. So they will be just ignored, right? So whichever is the minimum, that length you get. That's what you know. Whereas zip longest, if I do the same thing, observe carefully. For the remaining values also you are getting. Means whichever is longest, you get those many values. So for other things, if the values are not there, it will fill with a none. But if you want some other fill value, you can give that. And did you see? The fill value is 0. So depending upon your situation, you can go with something. Like this, there is one more thing like drop while. Means if you have a list, I'm creating a range of values and I'm asking even of list. I'm getting the values. Now, generally, filter function, right? Filter means if you give a lambda, if the condition is satisfied, all of them you will get it. Means if the number is greater than 2, you are getting the values. Same like that, Iteratools drop while is there. Means filter means what? If you have these many values, only these were satisfied with this condition, that's why you got it. Whereas drop while means whichever satisfy this condition, drop them. Remaining values you want. Means it's like reverse of the other thing, right? So whichever satisfies that condition, ignore them. So drop while, and so the remaining you give it. You see, drop while, which are the things which are satisfying this condition are like drop while. If it is less than 5, so drop while. And similarly, the same thing here, the remaining conditions also for the drop while. And same like a drop while, we have like a take while. Take while means it will filter the sequence items until that condition is true. So yeah, forgot to mention, sorry. So in the drop while and this thing, so filter means what? Only that conditions you are getting, right? So whereas a drop while, it will check when this condition will be met for the first time. So n is greater than 2. So when so x is greater than 2, till then it will do a filter. So after that it will not do filter. So once it becomes false, it stops the filter process. Means for all the values which are not satisfying in the starting before this, it will ignore. Or else observe this condition, you will understand. X less than 5, I am saying. Is 3 less than 5? Yes. So that's why you will not get it. So is 12 less than 5? No. So first condition is failed, right? So from this onwards, you get all the values. Only 3 is not coming. This may be thinking weird, but it works like that. So initially see here, x is less than 5. So 3 is following this end condition. So it will ignore. So 2 is following this condition, it will ignore. 7 is following this condition, means less than 5, no. So the moment this condition was broken, all other values will get. This is drop while. So similarly, take while means, so whenever a condition is met, so it's a reverse. So once this condition becomes true, it stops the process. Means if x less than 5 you told, 3 itself is satisfying, then it will not give anything. So it will give only 3. So if I say x less than 5, so I gave 3 onwards. And you see here, in this case also same thing. You get the values. So in a take while, so whenever the condition is true, it will stop there. And similarly, so they go for the take while in the next case, you will see. In the take while. So take while is like reverse of drop while. That's it. So for us to better understand, if I do like a combination of both take while and drop while, so you get the total list again. Means if you have one list totally, so if I do like a chain of these two together, you get the same result again. So drop means what? It will give all the values from the starting. So means ignore all the values from the starting till that condition is broken. Once the condition is broken, all the remaining values you will get. Whereas this will do the other side. And in the same fashion, we have star map. Star map means you have a ordinary power operation. So if I do like a power of some values, if I do like a map of some values, you will not get it. But if you do a power of star map, it will take a pair of values and do the power operations for it. So for each of the pairs, it will do a power operation do, or you can do a operator dot multiply or like anything. If you have a pair of values and if you want to do an operation for that pairs, star map is better suitable. So means like this, it can do. In the lastly, like a product also, this is also another interesting point. So quickly I will not take much time. If you have like 3 lists and if you want to get a combination, means a list within a list within a list like this. Instead of doing this much logic, you can do Iteratools.product of these 3. You generate the same number of values in both the use cases. So both will be same literally. Similarly, there is one thing like false filter. False filter, this iterator prints only the values that return false for the passive function. So means false filter means, so for this particular things, whichever is false, you are getting it. And similarly, if I say false is 0 there, so because I didn't give any condition literally, whichever is boolean 0, you are getting it. Boolean false is 0 there, that's why I got it. Whereas here, x greater than 0. So for whomsoever x is greater than 0, so filter them. So which r is less than that, then give it. So less than or so and so means which are the conditions. So reverse of filter. So filter means what are conditions are satisfied, only that you get. So it's a reverse. Then similarly you have a t function. So you can just walk through it. So a lot of things I added. So like this, a t function means like it will generate, it will return the values. If you have like a Iteratools.tree, so it will create, see here, I have one things. So from that it will create tree. So means like you see here, when I asked the values, you get like both two values. So it will return like any number of n number of independent iterators. So like this, if you can generate, means you can assign two values. So two values, three values. If you want to generate, by default it will not give. But if you pass like this, then it will generate those many iterables. Means from one list, if you want to create multiple lists, generally instead of you creating, you do like a t of some number. Then here you directly assign. So you need not worry. It will automatically assign the values. So every time I'm converting list because you can better see them. So that's the main thing.